Hi guys, welcome to the Characteristic Properties tutorial. I want to start with this question. Let's imagine that you're getting ready to do the baking soda lab that you just completed. And up on my front table, I have a whole bunch of white powders sitting in piles, and you have to pick which one is baking soda. This could be a problem, right? All white powders pretty much look the same. I mean, if you spend a lot of time with a particular powder, you might start to notice small differences in texture. But they mostly don't have a smell, and powders can be ground into different sizes, right? Sometimes powders can be chunky and sometimes they can be really fine. And you might find that the same substance can be ground up into a really fine powder, or it can be in bigger chunks, just like rocks can be broken into pebbles and so on. So, how do you pick out which of these white powders is the right powder? Well, you probably can't do it without doing some further testing. And that's what I want to talk about. How do scientists determine what white powder they have, or what metal they have, or what liquid they have? There are plenty of liquids that are also identical to each other just by looking. Water and alcohol look very similar. Sure, you could tell them apart by smelling them, but then can you tell one alcohol from another? I have two different alcohols that we use in my room. One goes into the alcohol burners, that's ethanol, and the other one we use in other experiments, it's called isopropanol. They're very similar smelling, they look almost identical, so it can be really hard to tell them apart. So what do we do? The answer is we use characteristic properties. Properties, we broke them down into physical and chemical, and that was one way to look at the different types of properties. But now I want to look at general versus characteristic properties. General properties are just any properties of a substance that we can measure and observe. Any trait at all can be a general property. Characteristic properties, though, are very specific measurable traits that are useful in identifying a substance or separating it from other substances. I want to use baking soda as our example here. So I have a picture of baking soda, and just to show you that how fine the powder baking soda looks like, it depends on how crushed up it is. I've shown you a picture there of baking soda that's chunkier than you're used to seeing it. The formula for baking soda is shown below with the little particle drawing, and I've also shown you in letters. So it contains these atoms: sodium, which has the symbol Na, oxygen, which has the symbol O, carbon, which has the symbol C, and hydrogen with the symbol H. So you can't see those particles, so there's no way for you to tell what your white powder is just by looking at it. Take a moment, pause the tutorial, and see if you can write down as many properties as possible that you know baking soda has. You know that it's white. What else do you know about baking soda? Come back when you're done and see what properties I've listed. These are certainly not all the properties that you could come up with for baking soda. These are just some of the ones that I want to point out. You could, in general, talk about the properties that baking soda has that describe it, but are not particularly useful in helping you pick it out from a bunch of other white powders. The color, size, luster, which is how shiny it is, the texture, its mass, its volume, its state, all those things describe your baking soda, but they could also describe any white powder. So all those white powders, for example, are white. All of them are similarly sized particles. All of them have low luster. They're not very shiny, they're pretty dull. All of them have about the same texture. I had about the same mass and volume of each one out there, right? They all were little small piles, and they're all in the solid state. So even though all those things describe those powders, none of them help us distinguish one powder from another. Skip over the middle for a second and come over here and look at these properties. By comparison, characteristic properties are useful in separating one of those powders from another. So one thing I could do is I could find the density of those powders. Each of those white powders will have its own unique density. Density is a measure of how close together the particles of a substance are. Since you can't actually see the particles, we have to measure density by taking the ratio of mass to volume. What I mean is, for 1 centimeter cubed of space, which is a little box about this big, how much mass is in that amount of space? And each of those white powders would have a different weight or a different mass because they have different densities. So for example, baking soda has a density of about 1.1 gram per little box. like that, 1.1 gram per centimeter cubed, whereas the heated baking soda, after we heated it, has about twice that amount of mass. It would be about 2.2 grams for that little box's worth. So that will tell you that you have, oh, one of these substances is way more dense than the other, and that might help you identify which white powder you have. Same thing with solubility. You found that after heating our baking soda, the heated baking soda was far less soluble in water. That's what made it difficult to clean out the heated baking soda test tube. You ran water in it and it just refused to dissolve. Whereas the unheated baking soda dissolved right away. And that's because the heated baking soda isn't baking soda anymore. It's another new white powder called sodium carbonate. We also found that the baking soda and the heated baking soda had different reactivities. They responded to vinegar in different ways. They both reacted, but the baking soda reacted much more vigorously. So how reactive you are with a particular substance, or whether you react with it or not, can help identify you. We also could have used melting point to distinguish our heated and unheated baking sodas. Baking soda will not melt because before it gets a chance to melt, it decomposes. It goes through a chemical reaction when we heat it, so it never gets a chance to melt. However, the heated baking soda, if we had an oven or a flame hot enough, we could have made it melt at about 850 degrees Celsius. There's another measurement that we're going to learn about for characteristic properties. It's called specific heat. Specific heat measures the amount of, the ability, I guess, of a substance to heat up or cool down. And we'll learn much more about that later. I don't want to talk about it now because it doesn't fit very well with baking soda. Usually you use specific heat to identify different metals. Some metals take in and release heat much more efficiently than others do. So some metals get hotter than others when you heat them, and some metals get cool off faster than others, and that can be useful in identifying what metal you actually have. Oh, and one other characteristic property that I forgot to put on here, that I'm just going to add in as an afterthought, is pH. pH. Little p, capital H. pH, it's not important what the letters stand for, but pH is a measure of how acidic or basic something is. It's a pretty technical chemical idea, hard to explain to beginning students because you're just starting to understand chemistry. But pH can be measured. You can determine how acidic or basic something is, and you can use test strips that turn different colors, or you can use liquids that you add that turn different colors. So let me show you, for example, a difference in the pH of your heated and unheated baking soda. So what you have here is the sodium bicarbonate, that's your baking soda. That's the baking soda. And over here, sodium carbonate, that's the heated baking soda. And they both look like plain white powders. And if you add them to a pH indicator solution, and there are lots of different ones, I like to use cabbage juice. Cabbage juice will turn different colors with different substances because of the differences in pH. You'll see that sodium bicarbonate, plain old baking soda, is a light pink, whereas sodium carbonate will give you this nice bright pink. And that's because pH is different for the two of them. The pH of baking soda, not that this means much to you, is around 8.9, and the pH of sodium bicarbonate is closer to 11. Just so you understand what that is, water has a pH of 7, so water is considered neutral. So anything above 7 is actually a base. Anything below 7 is considered an acid. So vinegar is an acid. So when you add vinegar to these two different basic solutions of sodium carbonate or sodium bicarbonate, then you get that vigorous reaction, because when an acid meets a base, they neutralize each other to produce water and to make a neutral solution. Okay, so characteristic properties, to sum up, are useful in identifying and separating substances from each other, and we're going to study several different characteristic properties and learn how to find them in the lab. So here is a quick list of the characteristic properties that we're going to focus on in this unit. You'll learn how to find all of these things. You'll learn how to define them. You'll find these things about different substances in the lab. And then we'll do a bunch of different projects where you'll identify substances. And then later on, I'll teach you how to use these properties to separate substances from each other. And the other thing we're going to do is we're going to use these characteristic properties to consider the question of, How should Flint, Michigan redesign their water system so that the characteristic properties that make up the materials in their water system make sense? Right now, they have a big problem because the characteristic properties of the materials they chose to build their water system don't match up well with the water source that they chose to use. And we'll talk much more about that as the unit progresses. See you guys in class.